Assalamualaikum dear students, this is International Islamic University Islamabad School's Sahiwal campus. Chemistry grade 9, lecture number 5, chapter number 4, structure of molecules. Students, bring your chemistry books, open them and write date, day properly. Listen to your teacher attentively and learn all the important points said by the teacher. The topic that we are going to discuss is nature of bonding and properties. Properties of the compounds depending upon the nature of the bonding present in them. So there are different type of bondings that may be ionic bond, covalent bond, coordinate covalent bond or the metallic bond. So first of all we will discuss the type of bonding or the nature of bonding and their properties in ionic compounds. Ionic compounds are made of positively charged and negatively charged ions. These positively and negatively charged ions are held together in a solid or crystal form with strong electrostatic attractive forces. So ionic compounds or the ionic bonds are basically formed by the complete transfer of electron from one atom to another atom. So these have positive and negative charges. The atom that lose an electron will gain a positive charge and the atom that will attain an electron will gain a negative charge. So these type of forces that held together in a solid or crystal form with strong electrostatic attractive forces are in the example of ionic compounds. The ionic compound have the following properties. Now we will discuss about the properties and what are the properties of the nature of bond that is ionic compound. The first one is that the ionic compounds are mostly crystalline solids. So the nature of the ionic compound is basically crystalline solid. They form crystallitis and solid in nature. Ionic compound in the solid state have negligible electrical conductance but they are good conductors. So ionic compound in their solid state are having negligible electrical conductance. They have a negligible value of electrical conductance. They do not be considered as a good conductor of electricity but they are good conductors in their solution form. If we form solution of the ionic compound, they will be a good conductor of electricity and also in the molten state. So it is due to the presence of free ions in them. In the solution form there are free ions present and if the free ions are present then the solution will be a good conductor of electricity. The third property is that ionic compound have high melting and boiling point. So the ionic compound from the crystalline solids, they have high and sharp melting and the boiling points. For example, sodium chloride has melting point that is 800 degrees centigrade and a boiling point of 1413 degree centigrade. So as ionic compounds are made up of positive and negative ions, there exist strong electrostatic forces of attraction between them. So if the compound having a positive and the negative ion, so the attraction between the opposite charged ions will be more strong. So they have a more strong forces of attraction between the oppositely charged ions. So a great amount of energy is required to break that type of force. The force that exists in between oppositely charged ions requires more and more energy to break it. They dissolve easily in polar solvent like water. Water has high dielectric constant that weakens the attractive forces between ions. So as they dissolve in the polar solvent, they itself are polar ionic compounds, so they dissolve more easily in the polar solvents. For example, water is a polar solvent and a universal solvent also. So water has high dielectric constant that will weaken the attraction between the ions, and if the attraction between the ion is weakened, so they can easily dissolvable. So here you can have example of crystallitis of sodium chloride. Each sodium atom is clouded by the 6 chlorine atoms. So one sodium atom will bind with the 6 chlorine negative charged ions in a crystal lattice. The next one is nature of bond and properties of covalent compounds. So the covalent compounds are made up of molecules that are formed by the mutual sharing of electron between their atoms are known as covalent compounds. So the compound that formed by the mutual sharing or that are formed by the sharing of shared pair of electron in between the atoms of that compound are known as covalent compounds. So general properties shown by the covalent compound are as follows. They have usually low melting and low boiling points. So bo- the compound that is formed by the complete sharing of electrons, so it will have a low melting and boiling point. They are usually bad conductors of electricity. They do not conduct electricity in a good amount. The compound having polar character in their bonding are conductor of electricity when they dissolve in the polar solvents. So covalent compound can be polar or non-polar in their nature. We have discussed in the previous lecture of this lesson. So the compound having the polar character means that they have polarity due to the electronegativity difference in between them. So in their bonding, so they are conductor of electricity when they dissolve in the polar solvent. They are usually insoluble in water but are soluble in non-aqueous solvent. Water is a polar solvent, so these are less soluble in water but are soluble in non-aqueous solvents like benzene, ether, alcohol, and acetone. These are basically non-polar solvents and non-aqueous solvents. Non-aqueous means having no water. Large molecules with three-dimensional bonding form covalent crystals which are very stable and hard. So the large molecules that form the three-dimensional crystallitis form the covalent crystals are very stable and hard due to their three-dimensional crystallitis and due to their low melting and boiling points. They have very high melting and boiling point in the form of crystallitis, so they are more stable and hard as other covalent compounds have usually low melting and boiling points, but in the crystalline form covalent crystals have very stable nature because of very high melting and boiling points. So if we discuss about the polar and the non-polar compounds, so about the Pauling scale, fluorine has been given an electronegativity value of 4.0. So the value for other elements can be calculated if we calculate in accordance with the fluorine. The property of the non-polar and the polar covalent compounds differ to some extent. Non-polar covalent compounds usually do not dissolve in the water, while the polar covalent compound usually dissolve in water, as water itself is a polar covalent polar solvent. So the polar covalent compounds will dissolve more easily. Similarly, non-polar compounds do not conduct electricity, but an aqueous solution of the polar compound usually conduct electricity. Aqueous solution means the solution of that non-polar compound in water. So the aqueous solution of the polar compound usually conduct electricity due to the formation of ions as a result of its reaction with water. So if the polar compound is dissolved in water, it will form an aqueous solution of that polar compound, so it will conduct electricity due to the formation of ions as a result of its reaction with the water. The next is coordinate covalent compounds. Their properties are mostly similar to those of the covalent compounds, as these are coordinate covalent compounds, and the coordinate covalent compound are formed basically by the relation of acceptor and donor relationship. The acceptor is that type of atom or the molecule or the ion that will gain electron by the donor, and the donor is that atom or ion or the molecule that will give up its electron to the other atom. So their properties are mostly similar to those of the covalent compound, as the nuclei in these compounds are held by the shared pair of electron. Therefore, they do not form ions in the water. Due to the shared pair of electron in between the nuclei, they cannot form ions in the water. Due to their covalent nature, they form solutions in the organic solvents and are very less soluble in water. Usually, they are rigid compounds with a dipole. Metals. Metals have following properties. They can show metallic luster. Metallic luster means metallic shine or the metallic nature to shine their surface. They are usually malleable and ductile. Malleable and ductile are the properties of the metal that can make them able to not to deform. If a metal is malleable and ductile, it will not deform if the pressure is applied to it. Malleability is the property by virtue of which a metal can be rolled into sheets. So malleability is that properties by which we can change a metal into sheets. We can make thin sheets of that metal and can be rolled into the sheets, while the ductility is the property by virtue of which metal can be drawn into wires. So the nature of wire the nature of the wire will be that of the nature of the metal. By the ability of ductility, the metals cannot be deformed, but changed into they can be changed into one form to another form. Deform in that sense, they do not change their crystallitis, or they cannot change their type of atom or the type of atomic structure or their three-dimensional structure, but they can be rolled into sheets and can be drawn into wires. They have usually high melting and boiling points. So the metals will have high melting and boiling point, as we have discussed previously, that the crystal nature of the molecules that have three-dimensional bonding of the covalent crystals do not have low melting and boiling point, rather they have stable and hard nature, so they have very high melting and boiling point. Being greater in size, they have low ionization energies and form cations very easily. So as the size of the metals are high, they have low ionization energy. Low ionization energy means they have the ability to lose the outermost shell electron more easily due to their larger size, and form cations and positive very easily. Cations are the type of ions that have a positive charge that is formed by the loss of electron. So metals are basically electropositive in their nature. They are good conductor of heat and electricity, as they have free electrons in between the atom of the molecules of the metals. So due to the presence of free electrons, they have high conductance of heat and electricity in the solid and liquid state, and this is basically due to the mobile electrons that are free to move in between the atom of that molecules. Okay students, this is end of the lesson. So you have to learn all the topics and all the important points that are discussed in this lesson. Allah Hafiz.